I would like to use this one example to explore the different ways that we can write a function. Given the ordered pair notation for the function f equals, and then the ordered pairs are -1, 1, 2, 4, and 3, 9, let's look at other notation for this example. First of all, general function notation looks like this. You'll have the name of your function, in this case f. You'll have a parenthesis, inside the parenthesis an x, and then equals y. Be careful about the parentheses. Normally parentheses means multiplication. In this particular example, it's nothing more than true notation. The f that starts the problem is the name of the function. The parentheses are indicating that the thing you're plugging into the function is x, and then equals y means that the thing that you're going to be getting out of the function is a y value. And so make a note that the f is the name, the x is what we call input, also known as an element of the domain, and the y is what we call output, also known as a range element. Now, first thing I want to discuss is what we call list notation. You will be familiar with this, being that this is what I use to introduce the idea of functions. You would have a domain element, range elements, and they're listed. So in this particular example, the domains were -1, 2, and 3. And then the range elements were 1, 4, and 9. And then you're going to make the assignments by using arrows. So -1 went to 1, 2 went to 4, 3 went to 9. The second kind of notation I will put to the right, and that is function notation. And there are two different ways to use function notation. This one is very specific in that it tells exactly which x goes with which y. The name of my function is f. The x value of -1 is assigned to the y value of 1. Function name is f. The x value of 2 is assigned to the y value of 4. Function named f has an x element of 3. The 3 is assigned to 9. So this is very specific function notation. All right, let's look at another way to denote these. We were given at the beginning of the problem a set of ordered pairs. All right, what we can do with those ordered pairs is we can plot them on an xy axis. So this will be a graphic representation. I had orders pairs -1, 1. I had an ordered pair 2 and 4. And we had an ordered pair 3 and 9. Looks like I'm going to have to extend my graph a little bit. Use your good imagination here. There's 3 and 9. So that graphic notation can be used to represent a function. Notice that it passes the vertical line test. In other words, the blue dots are the only parts that are actually in my graph. If I draw a vertical line, any line would pass it only once, and so it is indeed a function. From here, we can actually go straight to the way the notation was given to us originally, which was ordered pairs. So originally this was given to us as f equals the ordered pair -1, 1, the ordered pair 2 and 4, and the ordered pair 3 and 9. Okay, and then finally what I'm going to do for the last one is I'm going to refer back to the notation that I have here, and I'm going to see if I can develop some sort of pattern or some sort of formula. This is going to be function notation, but it's going to be general function notation. Alright, what I'd like to do here is I will say that my function name is f, I'm plugging in x, and then I want to know what do I do to x to get my y value out. Notice here that these are my x values, these are my y values. What could I do to 3 to get 9? What could I do that's the same as what I did to get the 3 to 9? How could I get from 2 to 4? What could I do to -1 to get to +1? It's easier on this one to start with the 3 and 9. One way to get from 3 to 9 is to do 3 times 3. So 3 times 3 would give me 9. Instead of thinking of it as 3 times 3, think of it as 3 squared. If I square the x value of 3, I get 9. Now, if that's going to be the pattern, it must work for each pair. Take the 2. What is 2 squared? 2 squared is 4, so it works for that one. It also has to work for the -1. -1 squared makes it +1 when I'm done. So the idea here is whatever x I'm taking, I can square it to get my y. And this particular example is only good for x equals -1, x equals 2, and x equals 3. Now, I can square any x value that I want, but for this example, the only x's that were in my domain were -1, 2, and 3, and it's important that we specify that at the end.